Welcome y'all back to some more geometry fun. We're talking about measuring angles and arcs. Let's kind of define some of this information first. So, a central angle is of course an angle where the vertices are at the center of the vertex. So for example, this right here is an angle, side, vertex, side. So this is our angle. It's a central angle because the vertex is at the center. It's at the center. Okay. Now the arc is the unbroken part that is bound between those two. So for example, here, this is our angle where the endpoints are on the circle. This is the arc. This is an arc. This is the distance between those two endpoints around the actual circle. Okay. This is the angle of that central angle. This is the arc of that angle. Now, a total circle all the way around is 360 degrees. This is right here. Now we have what we call major arc and minor arc. So major arcs in this case would be the red one. This is a minor, sorry. Minor arcs are anything less than 180. Anything less than 180, from 1 to 180, is a minor arc. If it's exactly 180, it is a semicircle. Anything over 180 but less than 360 is a major arc. So in this case, if this is the minor arc, distance from here all the way around this way will be our major arc. So this is our minor arc, major arc. So hopefully it makes sense. Minor, less than 180. Major is greater than 180, but it's less than 360. And a semicircle is exactly 180 degrees. All right, that being said, let's find some information. So let's find the value of all the arcs on these circles right here. So right here, this is a 90 degree in the angle. So here's the thing. One thing we did, I don't know if you saw. Whatever the central angle is, your arc degree is as well. So if this is 90 degree, the arc right here is also 90 degrees. Okay? And this is a straight line. If there's a 90 degree right here, then that means there's a 90 degree right here, making this 90 as well. If this half of the circle is 180, then this half right here, all the way around, is also 180 degrees. All right, so this one again, 90 degree angle right there, so that means this is 90. This is 120, making this 120. How will we find x? You're right, we're going to add those two, the 120 and the 90. What do we get? 210, okay? So that means between here and all the way to here, that is 210 degrees. To figure out the rest, since the whole thing is 360, we take 360 minus 210. Get 150. So this arc right here is 150 degrees. All right, let's find this right here. So they tell us this is 130 and this is 80. All right. These two are z, meaning they're the same. So let's look at this. This is 130, and we don't know what this is. We'll call this x for now. These two together, though, y'all, what does that make? Them two together. Yeah, you're right. It is 180. So we have 180 between them two. If we know one of them is 130, the other one will be 50. Correct. So making this 50. Here's the thing. The z is the same as z as far as the value of the degrees. So that's 50 degrees. That makes this 50 and this 50. And then that's 80. So we have 50, 50, 50, 80, and 130. So for your homework, you're going to have to find degrees, central angles, and arcs. They're the same. Central angles and their arcs have the same value. Central angles and arcs have the same value. Here's the thing. Central angle and arcs have the same value. And you're only hearing that. Central angles and arcs. There'll be other things, other angles, and other arcs. But if they're not central angles, then they don't have the same value as an arc. All right. Just kind of go on from there. Now, adjacent arcs are just like before. Adjacent means next to. Next to. So arcs that are next to each other. So for example, this arc right here is next to this arc. So they're adjacent arcs. They're right next to each other. They share this one point right here. Okay, so according to the arc addition postulate, that's saying that I can take any two arcs that are next to each other and add them up to make a bigger arc. So for example here, I don't know if this thing's in the way. Let me hide it. For example here, arc JN plus, so arc JN plus arc NT, JN plus NT, if I put them together, since they're a minor arc, that we call the new arc will be called JT. That's adding all this together. J and it won't be J and T, it's JT. And we'll talk about major and minor arcs, how to name them here in a bit. But this will be the new arc we're talking about here. So that being said, let's kind of look at this information. So here, say find the measurement, and the little m stands for measurement, the measurement of arc KL. So arc KL means you're going to add. So KL is pretty simple. So they're saying right here, like, hey, this percentage of the circle is 21%. Okay, we'll define the actual measurement in degrees. We're going to take 360 times 21%. So in decimal form, it'll be 0.21, 0.21. So get out your fancy dancy calculators, y'all. We're going to take 360 degrees, so 360, because that's a full circle, that's 100%, times 0.21. That gives you 75.6. So we can round that up to be roughly 76 degrees. About 76 degrees. Next one is NJL. So we're going from N to J all the way to L. So three letters means it's a major arc, and you follow the order, major. 2 letters is a minor arc. Okay, so if it's a 2-letter, you're going straight from K to L. So we went from K to L. We didn't go K all the way around here to L. No, we went from K to L. NJL is saying you go from N to J and then to L. So here, for the major arc, let's do that in orange. For this major arc, NJL, we're going to start at N. N all the way to J, and from J all the way to L. We're going to go around the circle. So that means we went through K, it stopped at L, because it tells us we're going from N to J and then J to L. So the order to tell you this is very important. They said N, L, J, J. We went gone here to here, all the way to here. Different amount, because we excluded that amount right there. So the order is very important. All right, N to J all the way to L. N, J, L, N, J, L. So what we're going to do is we're going to add these percentages up to kind of get the percent of this whole arc right here. So 26 plus 37 plus 21. What is that, class? Anybody got that yet? I don't yet. 26 plus 37 plus 21 gives us 84%. Okay, so this is 84%. You also could have added these two and subtracted that from 100 as well, but we did it the hard way. We added those, so that's 84%. So to figure out what percentage, what's the actual degrees of that circle, we're going to take 360 times 0.84. That's how you do that. 360 times 0.84 gives us roughly 302.4, which will stay as, if you're going to say to the nearest degree, it's just 302. All right. Now I tell you this because there's a question in your homework where it deals percentage, but if they give us actual numbers here, they say, hey, this is was 25%. See, 360 times 0.26. They told you this is 93.6 degrees from the very beginning, then this is 93.6. But here they gave us percentage, so we gotta add the percentage and take that to 360. All right, a couple more things. Now, this is just for formality. Congruent arcs are arcs that have the same measurement. So vertical angles, if they're vertical at the center, that means this arc and this angle and this angle are the same. These two angles are the same, meaning these two arcs are the same value right here. All right, and they told us, hey, this arc and this arc are congruent, and they also have the same marking for this arc. That means all three of these are congruent to each other. All three of them are congruent to each other. So in the same circle or in two congruent circles, two minor arcs are congruent if and only if their central angles are the same. So let's talk about word setting. If and only if means, well, it's a biconditional statement. If the angles are the same, then the arcs are the same, and vice versa. If they tell us that the arcs are the same, then we can assume that the angles are the same as well. Okay, that's what if and only if means. By condition, that means it's true forwards and backwards. So that's being said, hey, let's talk about arc length. The difference between arc measure, arc measure, as far as this is degrees. the measurement of degrees. Arc length is the actual length in feet, centimeters, so on and so forth. Now, it's a combination of the two. So in our equation, our proportion here, L stands for the length of the arc. This is in feet, centimeters, etc. Some actual measurement. Degrees will be your x, so degrees of the arc. So we got, now 2 pi r, what is that right there? 2 pi r stands for, yes, the circumference. Circumference circle. So circumference. So it's arc length over circumference equals degree of arc over 360 degrees, which is the degrees of the circles. So the length of the circle, degrees of the circle, the length of the arc, the degrees of the arc. So here, for example, let's say we're looking for arc AC. So what is arc AC? That's what we're looking for in this one. Here we're going to say AB, arc AB. What is AB on this one? So let's do this first one here. So we're going to set this up. We're going to say, hey, arc length, we don't know what that is, so that's our question mark, L, over 2 pi, and then the radius. The radius is 6 centimeters. So we're going to say 6 equals the degrees of the arc, which in this case we're going to say it's 140, over the degrees of the circle. And then we just cross multiply. So here 2 pi 6 is 12 pi. Now leave the pi as pi to the very end. So 360 times L is just 360 L. That equals 140 times 12. So 140 0 times 12 gives us 1,680. We're going to leave a pi on there. Pi. So 140 times 12. Yeah. And then to find L, we're going to divide by 360. Divide by 360. Divided by 360. So if you try to divide that evenly, it'll give you 4.666. So let's go ahead and multiply it. If we can't really divide it, let's go ahead and multiply it. Now you can reduce it. You got 168 over 36 pi. We can go and go for 168. I think we can divide that by 4. Yeah, we can divide that by 4. If we divide that by 4, we end up getting 42 pi over 9. And I think that's as low as it can in fraction form. Can't reduce anymore. So let's go ahead and actually divide it. So we're going to take 42. So I'm going to move this information over here. Oh, let me go. I'm going to take 42 times pi. 42 times pi equals 131.946 and so on over 9. And just divide that by 9. Divided by 9. That gives us 14.66. So we're going to do 14.66 centimeters, or we can round that off to be 15 whole centimeters, depending on the question. Either they'll tell you 2 decimals or they'll tell you all the nearest centimeter, nearest foot. All right, let's do one more right here. I'm going to do that in green so I don't get those confused. So here, we don't know arc length. We're looking for arc length, so that's our L. Arc length over 2 pi and the radius being 3 equals the degrees of the arc, 45. Degrees of the arc, 45, over 360. We can actually reduce that, 45 over 360, 60. I reduce to 1 over 8, so maybe we can do it. Let's do that. Let's reduce that to have to deal with smaller numbers. So here we get L over 2 times 3 is 6 pi equals 45 divided by 45 gives us 1, and 360 divided by 45. That gives us 8 right there. All right, so now if we cross multiply, we end up getting 8L equals 6 pi. Divide by 8. Arc length equals 6 pi over 8. That can reduce by 2. We end up getting 3 pi over 4. Now, let's go ahead and multiply that. So 3 times pi. 3 times pi. That gives us 9.424777, and we divide that by 4. That gives us roughly 2.35 feet, which rounds off to be roughly just 2 feet. All right. Part of the homework, you'll be doing this, so make sure you write this down. This will be your best friend right here. This information right here. All right. Hopefully that helps y'all. See you on a different day. Bye. Maybe. Okay. End this.